This is Ming from Renaissance Timing University. In this video, we are going to introduce the transmission line, which is interconnection between clock driver and clock receiver. So this is mainly used for board level design or system level design. So to connect between the two, driver and receiver, how do we treat this transmission line? So if the connection is very short, we can treat it as lump, so we don't have to worry about transmission line, just straight connection, simple connection. Don't have to worry about termination. If the transmission line, this connection is long, then we need to treat it as transmission line. So we need to control, we have a transmission line impedance control, and we need to have match load termination. So how long is long trace and how short is short trace? That will depend on the effective length. So anything shorter than 1/6 of effective length, we can treat it as a lump. If the transmission line the connection is longer than 1/6 effective length, then we can treat it as a transmission line. So the impedance need to be controlled and match load termination. So to calculate the effective length, it's come from signal rise time divided by propagation delay of the trace. For example, the signal have rise time of 600 picosecond, and the propagation delay have 150 picosecond per inch. So the effective length is calculated to be about 4 inch. And if you take effective length 4 inch, divide by 6 is equal to 0.67 inch. So if the trace length is shorter than 0.67 inch, then we can treat it as lump. And if the interconnection is longer than 0.67 inch, then we need to treat it as transmission line. So impedance need to be controlled and need to have match load termination. So the transmission line can be on the PC board can be microstrip or strip line. Between the board connection, system level connection, the transmission line can be a piece of coax cable, twisted pair wire, or a control impedance backplane. For example, for LVDS interface between LVDS driver and LVDS receiver through transmission line, this transmission line is control impedance of a differential 100 ohm. And that we need 100 ohm termination, match load termination, to match this transmission line. That's a simple termination for LVDS. For another example is for LV PACO driver, go through transmission line. Near the receiver, power supply VCC. So we need to have termination 50 ohm to VCC minus 2 volt. Wrong one. So this is standard termination for open emitter LV PACO driver. So from this termination here, we can derive to different type of termination that doesn't require any VCC minus 2 volt power supply. But for example, we can use Thevenin equivalent to eliminate this power supply to have a voltage divider at the end. So for more detailed termination, you can visit renesas.com for application note. Thank you for taking time to watch this video.